When we talk space news, it's so easy to get caught up in the wonder of distant stars or maybe some huge new discovery. And look, that stuff is fascinating, don't get me
Oh,
wrong.
absolutely. It's inspiring.
But what seems really clear now, like a major shift, is happening right under our noses. It's about the foundational changes, the real capabilities, and the economy we're building beyond Earth. Very tangible stuff.
You're hitting the nail on the head there. It's not just exploring anymore, it's systematic construction.
Hmm.
And the developments just from this past week, July 18th to the 25th, they really spotlight this critical maturation phase for the whole in-space economy.
Yeah, you see infrastructure, you see regulatory updates, real commercial drives.
Exactly. All coming together.
Welcome to Tomorrow Unveiled. Today we're doing a deep dive into Beyond Earth This Week in Space News. And this isn't just, running through headlines.
No, not at all.
We're looking at how these milestones connect, how they signal this really crucial pivot. Our mission today is to unpack the key insights, the important knowledge from the sources our dedicated research team pulled together. We're focusing on themes, on data points that keep popping up across different reports, stuff that's corroborated.
Yeah, we'll be digging into new power systems, new propulsion tech that makes these really long missions possible, and manufacturing, actually building things in orbit.
Right. And how low Earth orbit, LEO, is becoming this sophisticated data layer for the planet.
Mm-hmm. Plus, the ground infrastructure needed to support it all, which is critical, and even how, different countries are shifting their strategies for space.
And of course, you can't have this kind of progress without challenges, right? So we definitely need to touch on those too.
Sure.
Our research team pointed out that this week's news, it really highlights they called them the unglamorous but essential engineering solutions, the real nuts and bolts needed for a sustainable presence out there.
And what's really interesting when you look closely is how these different engineering feats, which might seem separate, are actually building three critical pillars, interdependent pillars for staying off-world.
Okay, so let's start with pillar one, power. That seems pretty fundamental, right?
Absolutely foundational.
For decades, deep space missions, they pretty much relied on plutonium-238, Pu-238 for power. But it's super scarce,
Incredibly scarce, a major bottleneck.
which has really limited how ambitious we could be with long missions.
Right. And that's where this Americium-241 breakthrough is such a big deal. Our research team found NASA Glenn Research Center, working with the University of Leicester over in the UK.
A transatlantic thing, okay.
Yeah, they successfully tested a Stirling generator test bed. Think of it like a really efficient engine converting heat to electricity. And it was powered by simulators of Americium-241 AM-241.
Simulators, okay, but proving the concept.
Exactly. And why it matters so much is it validates a viable alternative to plutonium-238. It gives us a second independent fuel source for these radioisotope power systems, or RPS.
So it's not just a theory, it's like a working model. How does this AM-241 actually, open things up? What does it let us do that was too risky before?
Well, it's more than just working. The specific type of engine they used, a free piston Stirling converter, it showed amazing efficiency and durability, perfect for missions lasting decades.
Decades, wow.
Yeah, and get this, it kept generating power even when they simulated one of the converters failing. That's huge for redundancy when you're, millions of miles away.
Can't just call roadside assistance.
Yeah, exactly.
Oh.
So this fundamentally de-risks the whole deep space exploration portfolio. For the U.S., for its allies, it enables much bolder missions, outer solar system stuff, or long stays on surfaces like Mars.
Okay, speaking of Mars,
Mm-hmm.
these long trips have another massive problem. Fuel just boiling away.
Yeah.
Cryogenic fuel loss, boil off. If you're talking years in space, you just can't afford to lose your propellant like that. Makes the whole trip kind of impossible with current tech, right?
Yeah, architecturally infeasible is the term often used. And that brings us right to the second pillar, tackling that zero boil-off challenge.
Okay.
So NASA Marshall Space Flight Center just wrapped up a huge 90-day ground test. 90 days.
Wow.
They tested this technique called tube-on-tank cooling for liquid hydrogen. Basically, cooling lines run right along the tank itself.
Keeping it super cold from the outside.
Kind of. It's an active cooling system, 2 stages. There's a primary loop with helium chilled to an unbelievable minus 424 Fahrenheit right on the tank wall.
Minus 424, that's incredibly cold.
It is. And then there's a second loop, a bit warmer at minus 298 F in sort of an intermediate shield. What this does is it intercepts the heat coming in before it even gets to the fuel.
So it stops the boiling before it starts.
Exactly. It effectively eliminates boil-off.
Okay, so no more running low on fuel halfway to Mars, which sounds pretty good after some road trips I've taken.
Right.
But, okay, if this zero boil-off really works out in space, what are the next, hurdles or maybe unexpected issues with using this on a massive scale for Mars?
That's a really good point. Ground tests are one thing, right? Proving it works reliably in microgravity, where fluids behave kind of weirdly sometimes, that still needs in-flight validation.
Makes sense.
But yeah, if it works, total game changer. Not just for sending crews to Mars, but for setting up propellant depots in space, like cosmic gas stations.
Yeah, stations in space. Love it.
And notice the connection here. Running these cooling systems constantly for years needs reliable, long life power.
Like the AM241 systems we were just talking about.
Precisely. These two advancements are deeply linked. One enables the other.
Okay, so we have power, we have fuel storage nailed down.
Yeah.
The next big thing for being truly self-sufficient out there seems to be, well, making stuff you need right where you are. No constant Amazon Prime deliveries from Earth.
Exactly. Avoid that massive shipping cost.
And this week saw a huge leap there, too.
That's our third pillar in space manufacturing. And yeah, a big milestone from ESA, the European Space Agency. The first metal parts 3D printed on the ISS, the space station. They just got back to Earth for analysis.
Metal, okay. Because they've been printing plastic polymers for a while, right?
Yeah, for years. But metal is a whole different ballgame. You get stronger parts, conductive parts, much more resilient stuff, crucial for actual construction in space.
That's a massive jump in capability, but, I mean, running a metal printer, something that precise in microgravity, that must be tricky. What were the big challenges they had to figure out?
Oh, definitely tricky. The printer itself is pretty hefty, 180 kilos. And it uses a wire-based process, feeding metal wire rather than powder, that helps avoid contamination, which is a big concern on the ISS.
Right, you don't want metal dust floating around.
Not at all. It uses a high-power laser to melt stainless steel wire at over 1,200 degrees Celsius. That's really hot. And it all happens inside a sealed box filled with nitrogen to stop oxidation and keep the crew safe.
Okay, safety first. So these samples are back on Earth now.
Yep. They'll undergo tons of testing. Scientists want to see exactly how microgravity affected the metal's internal structure, its strength, all that.
And the bigger picture here.
It's the start of a real shift. From Earth-dependent logistics, shipping everything up, to in-situ self-sufficiency. You ship raw feedstock like wire instead of finished parts. It makes missions way more resilient and paves the road for, eventually, a circular economy in space, maybe decades sooner than we thought.
Wow. Okay, that's huge for deep space.
Yeah.
But closer to home, in LEO, low Earth orbit. It feels like that's transforming too. Not just a place things pass through, but like you said, the data fabric.
Yeah, data fabric is a good way to put it. We saw some remarkable progress just this week in how we observe Earth and connect globally, all from LEO.
Like what?
Well, NASA's TRACERS mission launched July 23rd. Twin satellites, they're studying Earth's magnetic shield, space weather, but they're also testing some cool new tech. Things like a polylingual experimental terminal. Think of it enabling autonomous roaming, like a drone seamlessly switching between different communication networks. And also the Athena Epic modular sensor craft platform.
Sensor craft.
Yeah, it's designed to drastically cut the cost and time it takes to get new science instruments onto a spacecraft. Make it more plug and play.
That sounds useful. And more Earth observation coming up soon, too.
Yep, the NASA-ISRO NISAR mission, that's a U.S.-India collaboration, scheduled for July 30th launch. It uses advanced dual-band synthetic aperture radar, SAR.
SAR, that sees through clouds and at night, right?
Exactly, all-weather imaging. It promises just unprecedented data on ecosystems, climate change, natural disasters, giving us real actionable intelligence.
That could totally change disaster response.
Exactly.
Speaking of disasters, there was news about wildfires, too, right? A dedicated constellation.
Absolutely critical need, unfortunately. The Earth Fire Alliance released the first images from their FireSat constellation. These are purpose-built satellites.
What makes them special?
They have advanced mid-wave infrared sensors, super sensitive to heat. They can see through smoke, through clouds, and detect fires as small as 5 by 5 meters.
5 meters? That's tiny.
Orders of magnitude better than current systems. And Google Research is involved, too, applying AI to the data for predictive analytics, trying to shift from just fighting fires reactively to actually mitigating them proactively.
That's a fundamental shift. Huge potential.
Massive.
So we've got better eyes in the sky. What about connecting everything, powering these smart systems?
Good question. On that front, Airbus and OQ Technology had a world-first test. a successful 5G non-terrestrial network NTN connection.
5G from space.
Yep. Directly from a LEO satellite to a terminal on a flying drone. And they kept a reliable low data rate connection even while the drone was doing aerobatics.
Wow. And they used S-band. Why is that significant?
S-band is known for being robust. It can handle weather interference pretty well, good for reliability.
So this direct-to-drone 5G, I mean, how big a deal is that for things like autonomous drones, logistics, surveillance?
It potentially creates a whole new economic layer in the sky, a machine-to-machine layer. You could see mass-scale drone operations way beyond visual range, logistics, inspecting remote infrastructure, maybe even urban air mobility down the line.
A data backbone for autonomous systems, basically.
Yeah, a ubiquitous one. It's a clear precursor to a big new market. And just briefly on the human side, China's Tianzhu 9 cargo ship docked with their Tiangong station, delivered new spacesuits, longer-lasting ones, and a muscle training device to help astronauts stay healthy on longer missions.
Supporting that longer human presence. Okay, lots happening in LEO. Hey, just a quick pause here. If you're finding this insightful, maybe learning something new, please take a second to like this video if you're on YouTube, subscribe to Tomorrow Unveiled, and definitely hit that notification bell so you don't miss our future updates.
And if you're listening on a podcast service, maybe Apple Podcasts or Spotify, we'd be incredibly grateful if you could leave Tomorrow Unveiled a rating and a review. It honestly really helps us reach more people.
It really does. Thanks, folks. Okay, so we talked about these new capabilities, the buzz in LEO. It really seems like making this beyond Earth thing permanent hinges on building out the bigger picture, right? The orbital economy, the infrastructure,
Yeah.
both up there and down here.
You've absolutely nailed the core issue. And we're seeing this major trend towards space as a service. It basically lowers the cost and complexity for new companies to get involved.
Like cloud computing, but for space.
Exactly like that. Blue Origin, for example, just introduced their Blue Ring platform. It's designed as this versatile multi-mission spacecraft, like an in-space bus.
An orbital bus, okay. What can it do?
It offers transportation, it can host payloads for other companies, handle logistics. It's got serious propulsion capability, about 3,000 meters per second of delta V, meaning it can move around quite a bit in orbit, can carry up to 4,000 kilograms, and even has onboard computing for edge processing.
So companies don't need to build their own whole satellite.
Right. They can focus on their specific sensor or technology and just essentially rent a ride in orbital services from Blue Ring. Its first mission, planned for spring 2026, is actually carrying a sensor from a company called Scout Space for space domain awareness.
That definitely speeds things up.
Yeah.
But does this space as a service model raise any concerns? Like, could it lead to new monopolies or centralized control too much?
That's a valid question. It certainly lowers the barrier to entry now, which is great for innovation. Like you said, companies focus on their tech. Blue Origin handles the bus, very much like infrastructure as a service on Earth.
Right.
For the market to stay healthy, though, you'd hope to see multiple providers offering these kinds of platforms. Competition is key, but, orbital infrastructure isn't much good without the ground support.
Yes, the ground segment. And that brings us to Amazon's Project Kuiper. Big news there, too.
Huge news. Our research team highlighted this one. Amazon's new 100,000 square foot payload processing facility down at Kennedy Space Center. It's now fully operational.
100,000 square feet. That's massive.
It is. And it's designed for high throughput. They're talking processing over 100 satellites a month, supporting 3 launch campaigns at the same time. It directly tackles a major bottleneck for the whole U.S. launch industry, which is a shortage of modern processing space.
So Amazon building its own facility helps everyone, or mostly just Amazon.
Well, it certainly helps Amazon move faster, this kind of vertical integration, building their own satellites, processing them in their own facility, launching them likely on their own rockets. Eventually, it gives them huge control over their deployment speed. It creates what some analysts call a strategic moat to potentially outpace competitors like Starlink.
That vertical integration does sound like a powerful strategy. And the military, they're adapting too, right? Trying to tap into all this commercial innovation.
They are, and pretty strategically. The U.S. Space Force just formally restructured its Space Systems Command. They activated 2 new units called System Deltas. SYD-84 focuses on space-based missile warning, and SYD-810 on space-based sensing and targeting.
Okay, so new units. What does that change practically?
It's about aligning how they buy systems with how they operate them. Creates a more unified structure focused purely on warfighting needs. And crucially, it makes it much easier for them to pursue these hybrid architectures.
Hybrid meaning mixing military and commercial.
Exactly. Blending their own custom-built government satellites with services bought from commercial companies, like for communications or Earth observation, they can leverage this wave of commercial tech we've been discussing much more effectively.
Makes sense. And staying international for a moment, Japan had a key rocket test, too.
Yeah, JAXA, the Japanese Space Agency, announced a successful captive firing test for the first stage of their next-gen rocket, the H-3.
Captive firing, meaning they fire the engines, but the rocket stays bolted down.
That's right. It's a critical test to check the engine performance and the overall stage design, especially important since the H-3 had a launch failure previously. Nailing this down is vital for Japan's independent access to space and keeping them competitive in the commercial launch market.
Okay. Another big piece of the puzzle for a sustainable space economy is making satellites last longer. On-orbit servicing, refueling. Any news there?
Definitely progress there. Astroscale's U.S. division signed a Space Act agreement with NASA Goddard. They're going to use NASA's facilities to test the tech for their refueler spacecraft.
Refueler. It sounds straightforward.
The concept is, but the execution is complex. They'll be doing trials for rendezvous, flying close to another satellite, docking, all the tricky maneuvers needed to eventually gas up satellites already in geostationary orbit.
And why is that so important?
Extending satellite lifespans is huge. Saves money, reduces debris. It's considered a national security interest, too, keeping key assets operational longer. Plus, mastering these complex orbital robotics is key for everything else. Cleaning up space junk, building fuel depots, it's all connected.
Right, the robotics challenge again. And just quickly, more support for human exploration, too.
Yep. NASA selected the science instruments that will fly on its upcoming Lunar Terrain Vehicle, the LTV. That's the pressurized rover for the moon. These instruments will gather data on the lunar environment, look for resources, really helping to enable that sustained human presence on the moon.
Okay, wow. We have covered a lot of ground, or maybe a lot of space. Incredible progress, really. Power, fuel, building things, connecting things. It feels like we're accelerating fast into this beyond-Earth future.
It really does feel that way sometimes.
But like we said at the start, it's not all smooth sailing. There are still significant hurdles, right?
Oh, absolutely. The challenges are definitely real. Technical, logistical, regulatory, even financial.
Okay, let's break those down. Technical hurdles first.
Well, take the AM241 power source. Very promising, yes. But it has lower specific power than Pu-238. That means you need a bigger, heavier power source to get the same amount of electricity.
Trade-off.
Exactly. And also needs heavier shielding because it gives off more gamma and neutron radiation. So engineering challenges there.
And the metal 3D printing, you mentioned it was slow.
Yeah, very slow right now. Weeks for just small parts. And on the ISS, they can only run it a few hours a day because it's noisy and vibrates. Scaling that up for real efficient manufacturing, that needs major advances. It's not like hitting print on your desktop printer.
Not quite plug and play yet.
Not even close. And the cryogenic cooling. The ground tests are great, but fluids and microgravity can behave in really complex, sometimes unexpected ways. So proving it works flawlessly in space is still a crucial step.
Okay, technical challenges. What about logistics and regulations? Our research team flagged those consistently.
Yeah, they're huge. That shortage of payload processing facilities, even with Amazon building their own massive one, it's still a bottleneck for everyone trying to launch satellites quickly. There just isn't enough modern capacity right now.
And all these new satellites, especially the mega constellations, that must be causing headaches in orbit.
Massive headaches. Kuiper, Starlink, others. They are dramatically increasing the number of objects in LEO. This makes space domain awareness, SDA, basically knowing what's up there and where it's going, absolutely critical and urgent.
Because collisions are a real risk.
A growing risk. And we still lack universal rules of the road for space traffic management. Plus, tracking thousands of relatively small satellites is just technically very difficult. Orbital congestion is a serious problem.
And safety for humans, bringing industrial processes like metal printing into crewed environments.
Yeah, that's a big one. Operating that high-temperature printer on the ISS required extreme safety measures. As we move towards more complex manufacturing or servicing in space, especially near humans, ensuring crew safety becomes an even bigger challenge.
And the sustainability of LEO itself, with thousands more satellites planned.
It's a major concern. These mega constellations are the main drivers of congestion. We need responsible space stewardship. That means robust plans for deorbiting satellites at end of life, minimizing debris creation, and also addressing things like light pollution affecting astronomy. It's essential if we want LEO to be usable long term.
Okay, so technical, logistical, safety. And then there's a big domestic challenge brewing right now, isn't there, affecting NASA's budget?
Yeah, this is potentially the most immediate strategic risk to a lot of the U.S. progress we've discussed. Our research team flagged the serious internal upheaval at NASA right now. It's over proposed budget cuts for fiscal year 2026.
How bad are we talking?
The proposals are severe, nearly 50% cut to science funding, potentially canceling over 40 missions, and maybe leading to a workforce reduction of up to one-third.
One-third. Wow, that's huge.
It is. There have been protests in D.C. Lawmakers are concerned. Employees are obviously very concerned. The fear is that these kinds of cuts could really jeopardize U.S. leadership in space, cripple research programs, and lead to a brain drain, talented people leaving the agency or the field altogether.
Which would slow down future breakthroughs.
Exactly. Now, it's important to note Congress hasn't actually approved these cuts yet, but the internal planning reportedly includes issuing reduction in force, or RIF notices. So this budget battle is a really significant risk hanging over all this exciting progress.
What an incredibly packed week. Looking back, it's really clear, isn't it? These aren't just random advancements. It feels like a coordinated push across the board.
Precisely. It's systematic. The developments from this past week show this industry-wide effort to build the actual fundamental capabilities needed for a permanent human and economic presence beyond Earth.
We saw those three pillars getting stronger. Long-term power with MM241, efficient fuel logistics with zero boil-off tech, and that on-demand manufacturing with metal printing.
And at the same time, that sophisticated data fabric is really taking shape in LEO, connecting and observing the Earth in new ways.
So looking ahead just a bit, what are you watching for next? What are the near-term things you're most excited to track?
Oh, definitely the in-flight demonstrations of those cryogenic fuel management systems, seeing if the zero boil-off tech works as well in space as on the ground. That's huge.
Right.
Also, the first operational launches of the FireSat constellation, seeing that wildfire detection system really scale up, and the first flight of Blue Origin's Blue Ring platform will be fascinating to watch.
At Space Bus.
Yeah, and expect the race to build ground infrastructure like those processing facilities to just intensify. Plus, watching how the Space Force actually implements those hybrid architectures, blending commercial and military systems, that will really show how much the commercial sector's influence is growing.
Lots to keep an eye on. We absolutely love hearing what you think. If you're on YouTube or listening on your favorite podcast app, drop a comment. Let us know what stood out to you from this week's space news.
It really feels like these advancements are bringing that dream of a sustained presence beyond Earth closer than ever. It's becoming more real, more tangible. But as we've discussed, navigating the challenges technical, logistical, financial, and ensuring we do it responsibly, that's going to be absolutely key.